51 a prime number? Yes or no? What do you guys think? Is 51 a prime number? Just a quick guess. You can be wrong. No. Okay. 51 is not a prime number. It turns out that 51 is not a prime number. The reason why 51 is not a prime number is 51 is, whoa, oh man, where's my fact? Man, don't tell me my fact is gone. Oh, I never copied and pasted it. Whoops. 51 is not a prime number because it's divisible by 3. Now, there's a trick. If you didn't already know this, I love this trick, and I always show it off because it's one of my favorite tricks. You can test if a number is divisible by 3 super quickly. All you need to do is you need to take all of the digits and add them up. So if you take 5 plus 1, right? 5 plus 1 equals 6. And the question then becomes, is 6 divisible by 3? 6 is divisible by 3, so therefore 51 must be divisible by 3. It turns out it is, 51 is 3 times 17. So 144, who wants to tell me, is 144, well you guys should know this already, but if you don't, is 144 divisible by 3 using that same rule? In chat or out loud?
Yeah.
Yeah. It is, because what you would do is you would add 1 plus 4 is 5 plus 4 equals 9. 9 is divisible by 3, so 144, which is 12 times 12, which you guys should know is divisible by 3. What about 245? Is this guy divisible by 3?
No.
No, it's not. 2 plus 4 is 6 plus 5 is 11. 11 is not divisible by 3, so therefore 245 isn't divisible by 3. But even if you take some ugly thing like this, what do you guys reckon about this one? Yes or no?
Yep. Yep.
This one, 1 plus 2 is 3, plus 7 is 10, plus 8 is 18, plus 3 is 21. 21 is divisible by 3, and if you didn't know 21 was divisible by 3, 2 plus 1 makes 3. So therefore, this whole number is divisible by 3. This is a quick, neat little trick that I show, especially younger students, because when it comes to simplifying fractions, sometimes it can be a bit hard. So if you get something like 18 divided by 51, you know, knowing that both of those are divisible by 3, you may miss that. So you may miss that simplifying 18 over 51 turns into 6 over 17. You might miss that because you don't know that that's the case. But anyway, let's go back to today's lesson, lesson 51, creating inequalities. We'll be able to convert a graphed inequality into algebra. So how do we go about doing that? Before I do that, let me just show you what we did last time. Last time what we did was we graphed inequalities for the very first time. And so how we did that is we took an equation. In this case, we took this equation. First, I showed you guys how to check if something's in a region. You can easily check if something's in a region if you substitute it in and it makes sense. In this case, 2 times 5 makes 10, minus 15 is negative 5. Is negative 5 greater than 12? No, it's not. So therefore, this is not in the region. How we did the second one is we said, well, we've got this big equation here. What do we need to do in order to plot this? In order to plot this, we went negative 5y. We said in this case is equal to and we said 20 minus 4x. The reason we did equals to is because what we were trying to do is we were trying to convert this into a straight line first so we could plot it. What we ended up with is we ended up with a plot. I can't remember exactly what the plot was like. I think it was y equals, it must have been -8 or something. I think it was like something like that. I can't remember exactly. But yeah, we figured it out and then we shaded it in. Today what we're going to do is we're going to do 2 examples. I've got, as I said, I've got this example here, and then I've got another example as well. Now, we don't have to do this second example, but I'm putting it here in case you guys want to do it. And then I've got this example here. Now, what we're going to do is we're going to figure out what this inequality is. And then what we're going to do is and then we can do this example here if you guys want. But I'll leave this up to you guys as we go. And then what we'll do is I'll talk to you guys about the work that I would like you to do as homework and stuff. I'm going to try and do this relatively quickly because I've already spoken to you guys for a long time and I want you guys to work through this stuff. So we're going to do this one here. I'm going to set up my pad to do this one, but can I get you guys to copy this down here for me? Okay, so the equation that it asks us to plot down, or the inequality that it wants us to plot down, is 2x plus 3y must be less than or equal to 12. It wants us to plot this equation. Now, how you plot this equation, and there's a couple of ways you can do this, but again, I'm going to show you the way that I would do it probably, is I would start off with, let's just call it 2x plus 3y equals 12. Let's just call it that for the meantime. We know that this is the case, but we're going to call it this for the meantime. Because then what we can do is we can say, well, 3y minus 2x on both sides equals 12 minus 2x. And then I can divide both sides by 3. Y equals 12 divided by 3 is 4. And then we've got minus 2 over 3x. Okay, cool. Now we've got it in gradient intercept form. So now we can plot this line. Now, plotting a line is, in my opinion, the most important part. Once you've got yourself a line, you guys can figure out the rest. We can figure out the rest of it later on. Plus, plotting the line is worth, you know, a couple of marks already. So all right, so let's do this. Let's plot it. So we've got, if we're going to plot it, we've got a point at 4. So 1, 2, 3, 4 up here, because that's our y-intercept is at 4, c equals 4. Our gradient is -2 over 3, which means we've got a rise in -2 and a run of 3. So we're going to go down 2, 1, 2. We're going to go across 3, 1, 2, 3. Just about there. I'm going to call that, that's going to be 2, is going to be 3, 2, just in case. Straight edge, point, point, line. Okay. Now, so far, all we've done is we've turned this into a linear graph, and then we've drawn that linear graph. We actually haven't done anything in linear inequalities yet. But this, in my opinion, and this is what I'm trying to teach you guys, this is the main guts of it. Okay, this is 60% of it is stuff that you guys already know. The last little bit is a little bit easy. All you need to do is choose a point, either on this side or this side of the graph. In this case, I'm going to choose this side of the graph. I'm going to take this point here, 0, 0. I'm going to say 0, 0. And I'm going to check, is it in the region? In region. How do I check this? Well, I take 0, 0 and I put it up here. 2 times 0 plus 3 times 0. Is that less than 12? Well, 2 times 0 is 0, plus 3 times 0 is 0. Is 0 less than 12? Yes, 0 is less than or equal to 12. So therefore, I know that this area down the bottom is the included region. So, or the, so all this part of the top here is not included. So that's why I then color it in. And because it says less than or equal to, I need to make sure that this line here is a solid line. I always forget that when I do these questions. I should have done this as a dotted line first and then bolded it up. But in this case, I forgot, but it's okay. So that's how I do these types of questions. Let's break through the steps really quickly. First, I turn it into a linear equation. Then I graph that linear equation. Then I choose a point. And once I've chosen that point, I then say, is it in the region? If it is in the region, then that's the other side gets shaded in. As I've told you guys before, you could just look at this and sort of say, oh, because less than means below the line, but I usually end up making mistakes because of that. You might not always be able to choose 0, 0, because 0, 0 might be, the line might go through 0, 0, so you may have to choose a different point, but in general, you can.
So what was the shaded area again?
So the shaded area is the, in this case, is the non-included region. It's the region that doesn't work.
Okay, okay.
Now, as I said, usually what we'll do is you will see, usually what you'll see is different, or you can refer to, you can call this the included region or the region, sorry, let's see, make sure you guys can see this, or you can refer to it as the region required. So I've been talking a bit about this to Miss Bakak, who's, is another general maths teacher, and just how we go about teaching this stuff. And so she's sort of the opinion, I sort of said to her, whoops. She's sort of the opinion that that I am, which is that it's better to have a legend or a key down the bottom so that you can tell what's going on here. Some tests, some questions, some workbooks say the region required will be the shaded region. Some will say the region required is going to be the blank region. I'm going to be sticking to teaching you guys that the region required is the blank region because it'll help later on. But I will always include a legend so that you guys know what's going on. Now, let's have a look at the time. Okay, 10 o'clock. Question for you guys is this. I want to go through this exercise with you guys, but before that, I have got another graphing one. Do you guys want me to graph this one Or would you guys want me? I'm going to leave it up to you guys. I'm going to get a quick vote from chat or out loud. Would you guys like me to do this one, or would you guys like me to move on and do the next one? Graph it, please. I got one grapher from Bayou. Is there anyone else that wants me to graph this one? Luckily for it's, I don't mind. It is important because, like, yeah, it is important because this will eat into the time that you've got today to work outside of class and stuff. That's all. That's the only reason. All right, because no one else has said anything, I'm going to go with what value wants, which is we're going to graph this one. So we're going to graph y is greater than x. You will have to draw a new little thing, and then I'm gonna plot this one for you. Okay, so plotting this one here, y is greater than x. How do we go about plotting this one? So again, I'm going to do the very same thing that I just did last time. I'm going to go y equals x. I'm going to change that inequality straight into a format like this. Now, I actually don't need to do much here. So I'm going to do this line here, down to 10, point here 5, we go across from 5, like that, straight across. Doesn't have to be exact. Okay, so now y equals x. Okay, so that means that we've got a gradient m, which is 1 because the 1 is in front. We're going to see y intercept is 0. So y equals x is actually really easy to draw. I'll put a point here at 0, 0. Go across y is 1, run 1. And we get this line here. Oops. And that line there represents when will he learn? When will he learn? I'm going to do a dotted line first in case this is a greater than symbol. I never learn. So this is now point here is at 1, 1. I'm going to put that in there just so that people can tell. Now, now that I've got this line drawn, the next step would be, and because I know it's greater than, it's a dotted line, not a solid line. If you make a mistake like this, you should do your test in pen, but for your graphs, you can use Greylet if you want, but this is a great reason to use Greylet because you can rub it out. In this case, we've got y must be greater than x. So I can't test 0, 0 because 0, 0 is on the line. So I'm just going to test a random point. I'm going to test this point. I'm going to test, let's test this point here. Doesn't matter, whatever. That point is 5, 1. So 5, 1. So we're going to test if 5, 1 is supposed to be in the graph. You can choose any point. I just chose this one because, I don't know, it's clearly in the bottom half of this graph. So we're going to substitute 5, 1. So in this case, 1 is greater than 5 is because that's what 1 is going to be our y value and 5 is going to be our x value. Is 1 greater than 5? No, it's not. So therefore, this part here is not in the region. So that means that's the part that I cross out. Only this part is the part where y is greater than 5. So we're going to write down here, blank is the region required. This region at the top here is the region required. And I could have taken this point here, like 10, 0. Is 10 greater than 0? Yes, it is. So then that would work. I could have taken even this point here, negative 0, negative 4. Well, 0 is greater than negative 4, so therefore that's in the region. And that's how I would do that one super quick. But yeah, like just so you guys can see, those are the steps. Step 1, convert it into a linear graph. Step 2, plot it. Step 3, check a point. And then step 4, shade. Try and do better than me, and remember to do a dotted line on this first, and then if it says greater than or equal to, then you shade that line in. But I always forget. It's up to you. So now I've got at least one more example I want to do, which is here. I want to show you guys a new skill. So those were two of the same skill that I showed you guys on Friday, but this is a new skill here, which is going to be looking at this. I've got here a line and a shaded area, and I've got the region required, in this case, is down the bottom here. And I'm actually going to show you something. I'm going to show you guys how to go backwards. How can we find out what this inequality is? So we're going to do the same things that we did last time. We're going to go sort of backwards. We're going to figure out first what is the equation of the line. Now, to find the equation, oh my God, I'm going to kill myself. Equation. To find the equation of the line, what you need to do is you need to go, well, let's take this point here. That's point of 1. That's our y-intercept. So c equals 1. That's our first value that we've got. C equals 1. That's our y-intercept. Now our gradient. To do our gradient, I think it'd be easy just to take this point here and to see that that's a run of 1, 2, and a rise of 1. So m equals rise of run and then rise of run in this case is going to be, that's the worst. Oh, where's my mouse? Rise of run, which is in this case 1/2, because it goes a run of 2 and a rise of 1. The other thing as well to pay attention here is it's positive because the line slopes up to the right, so therefore positive. So that gives us the equation y equals 1/2 x plus 1. Now, if you then wanted to then figure out, well, how do I turn this into an inequality, just like how we did last time? Now that we've got a linear equation, how do I turn that into an inequality? Well, the next step is to go, well, that's going to be the equation. To turn this into an inequality, you just got to choose a point. Let's choose 0, 0. Now, in this case, 0, 0 is in the region we want. The reason we know 0, 0 is in the region we want is because of this here. It is in the region required. It is in this region here, the light region, the good region, not the shaded out region. So if I substitute 0, 0 in, I get 0 equals 1/2 times 0 plus 1. Sorry guys, I don't have my mouse with me in the moment. So that's going to be equal 0, 0, and we're going to have 1. Now, because 0, 0 is in the region, right, we want this to be true. I'm not sure if that makes sense, but we want this to be correct. So because we want this to be correct, we want 1 is greater than 0. That is correct. And because we know that this is correct, this is the symbol that goes back up into here. Y is less than a half x plus 1. So let's talk about this again, just so you guys can see. Because we want this to be correct, that's why we know that the graph is like this and not the other way around. It's not, if we wanted it to be, and that's why you should always choose a value that's in the region, because then it's easy to make it correct. It's hard to be like, oh, this is not in the region, so I've got to make it false. But yeah, that's how I figure out an inequality. The reason that it's greater than and not greater than and equal to is because this line is a dotted line. Have we got any questions or queries about this?
No.
Okay, so now my last question is, I've got one more example, which is here. Would you guys like to do this example, or would you guys like to instead start working on the questions? It's up to you guys. I've got Vayu wants to move on. Questions? Okay, so I think a lot of people now want to give the questions a go. Okay, cool.